Hey there, I thought I'd give a quick overview of the Kestrel library. This is a library that lets you write queries that pull data from multiple kinds of data sources. So you can pull from SQL, pull from, an external HTTP service that's providing some data. You can pull data from, I don't know, the local file system, in-memory data, whatever you want, and you can mix all of these together in a single query. All the data sources show up as typed values in Unison, so you get the benefit of a type checker as you're writing your queries. And of course, you can introduce new reusable functions and abstractions. You can abstract over different queries. You can have higher order queries, whatever you want. And it's meant to be super nice and high level to program with. So a goal of the library is to make it a lot easier to write sort of glue services and applications. So anytime you're sort of pulling data from multiple places, it it would be great if you could just sort of have the business logic nice and clean and pure, and all of the other stuff of like talking to these data sources is sort of pushed to the outside of your application, so that the actual business logic stays nice and clean. Um, yeah. So one of the issues that can sometimes happen if you don't have a library like this is that the business logic and sort of parsing and networking and that sort of stuff can be sort of intermingled in a way that's less nice. Um, the other thing that was a goal of this library is I wanted the query language to be very powerful and nice to work with. So instead of having to write explicit loops everywhere and sort of do that kind of thing, you get this very declarative API, much like SQL. Cool. So I'll go through a little bit about the query language, and then I'll talk about binding to external data sources. So here's a really simple query. We have two sort of just in-memory tables that we're declaring. One that maps usernames to user IDs, and the other that maps user IDs to favorite fruits. And we're just saying for each of Alice, Bob, and Eve, we're going to pick out their user ID and then use that user ID to pick out their favorite fruit. And then for the final result, we're just returning a pair of the username and their favorite fruit. You can see that like Alice has user ID of 1, and the favorite fruit of user ID 1 is this apple. So you can kind of see a little bit of the sort of implicit parallelism and non-determinism here. So we don't have to write an explicit loop to loop over Alice, Bob, and Eve. We just say, hey, we're running this query for all three of these. And the query interpreter is going to take care of actually making all that happen. So one really nice thing about this approach is it gives the query interpreter a lot more flexibility. So the query interpreter is free to do things like parallel execution of subqueries and things like batching, and you don't have to write any of that stuff. You just write a nice declarative query that looks something like this, and all that stuff can just be taken care of when you run the query or by the query interpreter. The library currently has two interpreters. One is just a sequential interpreter that kind of runs things kind of in the order that you would expect. There is also a parallel, or I guess there's two parallel interpreters that will run things in parallel, and there's actually a few flavors of that. So very powerful, a lot of things you can do. Here is a quick overview. So the library has really good documentation, which I encourage you to check out. But this just shows a little bit more about the querying API. So obviously you can select, for a given key, what are the values that are associated in this data source. So that's kind of like the core thing, is a select of a key. You can also sort of non-deterministically iterate over multiple values. It's even kind of interesting. You don't even need to name the value when you say query.each. So you can just say select query.each Alice Bob, and then just literally right there. And now it's going to repeat this query for both Alice and Bob. Yeah, so there's union, you can limit the number of results, you can, filter results, to match some predicate, and so on and so forth. Yeah, another one is cascade. It's kind of interesting. You can run a query, and then only if that query returns no results do you run some other query. There's a number of sort of runners or interpreters of queries. Some of these are just convenience functions, but yeah, kind of the main ones are run and par run or par run chunked. So you can, either get back a list of results or do the same, but with parallelism. Okay, the last thing I'll mention is tracing, which is kind of interesting. So sometimes when as you're building a query, you might want to just observe, like, oh, maybe some subquery is returning no results when you were expecting it to. And so you might want to look at a trace of the query. And so there's a few functions that end in traced that let you do that. Okay, so yeah, you can check out the docs for more. I'll post a link in the description as well. Okay, so I wanted to show one other thing. This is a more interesting example that is pulling data from multiple sources. So one is just this in-memory index. So this is a mapping from a city name to a latitude-longitude pair for that city. But then we also have this weather by location index, which is mapping latitude-longitude pairs to a weather forecast. Okay, so a couple things. So first of all, notice that these data sources are typed. So, the data source doesn't show up as, like, I don't know, a URL, and then you like make a request to that URL and have a bunch of HTTP parsing and serialization code. And that's all going to be encapsulated in the data source itself, so that all the queries that make use of that data source don't have any, parsing or serialization or networking code that they have to write. They just focus on the business logic of just, cool, we're pulling data from this data source that somehow provides weather forecasts for any location. So yeah, they're typed. These index values are typed. Let me just show. I'll just jump to the index type for a sec. So what is an index? This is the abstraction for a data source, and it is really simple. It is a function, an index kv. It's a function, essentially a function from k to a stream of values of type v. The stream is allowed to make use of effects. So g may be something. So if it's pure, then g is empty, no effects. But the HTTP, the weather by location example, is you can see the effect is actually remote, because it's going to be making some HTTP calls each time you ask it for the weather for a latitude longitude pair. In terms of how this particular data set works, it's just issuing an HTTP call to this API that gives you weather forecasts. And so it has to encode the latitude longitude pair into some query parameters, and then when it gets the response, it needs to decode the response, and there's some JSON decoding there, which I won't go into, but this is like what the JSON looks like that you get back, and this is what we end up decoding it to. And the decoder is whatever. This is just some JSON decoding logic. But yeah, the nice thing is that stuff is dealt with in one place. So you deal with it in this binding to the data source, but then what you expose is this nice typed interface to the data source that you can make use of in your queries. Cool. So I think that's it. But yeah, I'll leave a link in the description to check out the library, and let me know what you think.